afternoon. I will present you my work of analyzing snowfall observation and evaluating different models over the YOPP period campaign at Dumont-dUrville in Antarctica. So, in fact, the climatic interest is the most important motivation for analyzing precipitation, especially in Antarctica, because precipitation is the main term of the surface mass balance on the ice gap at the surface, and so this is influencing directly the sea level rise when precipitation evolves. So it is really important to better understand precipitation, and this is starting from the meteorological scale, as we want to do better prediction. And as you may know, to better those predictions, we require a lot of observation, and in Antarctica, especially on the coast, these observations are rare and of poor quality because of the extreme weather conditions. So the precipitation, traditionally, they are studied at the surface. But this is a limited approach because it does not take into account all the vertical column, and we want to know all the processes that occurs in high altitude, especially in Antarctica, where there are many processes at the lower levels. For example, sublimation and blowing snow, and this is two things, for example, that are really impacting the surface precipitation, and this is the thing we want to know. So my study is located on Dumont-dUrville. This is the station at 5 kilometers on a little island of the east coast of Antarctica. It was selected to be a supersite during the YOPP campaign at the South Pole. This is one of the few stations where you can find the Météo France station, scientific base, where many measurements are done, especially there are radiosondes that are launched daily. And during YOPP, we have 3 radiosondes per day. And also, during YOPP, we have a lot of other observations that I will tell you more about that later. Also, there are other projects that have been launched in Dumont-dUrville, and this is another part of our observations. And why Dumont-dUrville is interesting is the fact that it is on the East Coast, and it is really representative of the East Coast. So we can learn a lot of this region just analyzing this place. So for the surface snow precipitation measurement, it was done with a snow gauge, and this instrument was installed during another project some years ago. It is après-3, and it's still operational right now also. This one measure, in fact, the precipitation by measuring the mass change, mass variation, and of course there are a lot of error because of the wind, and the wind, in fact, is inducing phantom mass, and so we have a lot of occurrence of wrong precipitation events. Then in altitude, we have two methods of measuring precipitation in altitude. We have the in situ method, because we have a Doppler radar directly on the Dumont dUrville station. It was also installed during the Laboratoire project. This is a rain radar at the start, but there was a calibration using a second radar, which was then removed, and in fact we use conversion formula to convert the measured reflectivity into a snowfall rate and not a rainfall rate. This radar provides information every 100 meters, and the first level is really useful because it can remove, in fact, the phantom mass recording of the snow gauge that I just presented to you. The second method of measuring precipitation in altitude is the CloudSat radar, the radar that is in the CloudSat satellite platform. The little problem with this radar is that the CloudSat satellite was not functioning after 2010. Really, we have 4 years of correct functioning, and we can only use 4 years to do a little climatology. So 2 people worked on doing the first climatology of precipitation in Antarctica at the surface by Cyril Palerme, and then in altitude by Florentin Lemonnier. For our modeling dataset, we are using some various models and simulation, and some simulation have been done just for the YOPP campaign. For example, we have the arpège model. It was used on its grid centered on the Dôme C, which is another station closer to the South Pole, and it is about 100 kilometers of Dumont dUrville. And in my lab, we launched the LMDZ model with a zoom on Dumont dUrville. And for LMDZ and the MOR model, we use the ERA analysis for forcing. Then the method of evaluation of models. So we choose to compare precipitation occurrence and precipitation quantities, both quantity and occurrence. So we considered that each day of the YOPP campaign represents an independent precipitation event, and we choose in each model the closest response to the real coordinates of the Dumont dUrville station. We also only take into account significant precipitation events by defining a minimum threshold, and so we remove what we think it is digital precipitation. So here you can see the contingency table we use to sort out different events. And from these results, we calculate some scores. So there is bias, probability of detection, fails alarm ratio, and the 8 skill score. So we try to calculate these scores for each model at the surface and at each vertical level, and we compare these to the perfect score. So 1 for bias, probability of detection, and a skill score, and 0 for the fails alarm ratio. So I will present you quickly the results and then summarize what we saw. So on the left, there are the time series of the precipitation occurrence for the different model, and these are compared to the observation. So for the surface, the observation, the reference of observation is a snow gauge, and then at the right you can see a vertical profile of the accumulation of the different model compared to the quantities that are measured by the radar. And you can see that the colors at the left are in fact representing the agreement or disagreement between the different models and the observations. So here are the numerical results. So you see that both at the surface, which is represented by 2D, the column 2D, and at altitude, which is represented by the column 3D, we have scores for each model, and the worst scores are in red and the best scores are in green. So what we learn quickly about the different types of model we analyze is that the reanalysis and the operational models benefit from the assimilation of observation. It allows them to have a good detection of precipitation. That's what we can see with a good pod score. And especially at the surface, and we can suggest that this is because their dynamics are forced. But the reanalysis also overestimate the quantities and the occurrence of precipitation, especially on the vertical, and this results in fact in a strong bias that we saw on the table just before. And this is explained by numerous false alarms and a wrong shape of vertical profile. And this may be due to a problem with physics. So this is for reanalysis and operational model. And for research model, we studied LMDZ and MAR. They do not well represent precipitation events because they do not have a good shape of vertical profile, but they have average score, especially at the surface, because there are error compensations. So just quickly, with the satellite data, we can only do a seasonal intercomparison between what we have in situ with the radar at Dumont dUrville and what we have thanks to CloudSat. So it is interesting just to note that the YOPP summer season was really dry at Dumont dUrville, but the little problem is that the CloudSat grid point, the closest CloudSat grid point in the climatology, in the Antarctic climatology, is wetter than the average over the coastal region of Eastern Antarctica. So there is an underestimation of the total vertical accumulation, and this may be due to many intense events that are missed by the satellites due to the low satellite pass frequency over the region. And we can say that because the main contribution to the total precipitation in summer can be due to the intense event. So a study like YOPP is very interesting at Dumont dUrville to detect the common and different behaviors in the region like the East Coast in Antarctica. Thanks to the high frequency of observation in a short period of time, and this is really rare. So now we are trying to find an explanation for the different bias we saw in the models and try to generalize these conclusions, and also to assess the robustness of the result coming from different reference of observation at the surface and in altitude. And the vertical precipitation profile is another thing to add to the precipitation study. This is something new, and we can continue to study that thanks to the radiosonde. Thank you.
Time for a very quick question, if anyone has one.
Just regarding CloudSat, that one is still in orbit, right? Was that just a period when it was non-operational, yes, and then it came back?
No, it is also operational right now, but in fact we only, I think there is a problem with the battery, so we don't have night measurements.
Okay, thanks.
Okay, thanks. Thanks a lot.